Hi, my name is Sarah Virnig, and today I will be discussing with you our 6 homework questions from Chapter 8, Algebraic Reasoning, Graphing, and Connections with Geometry. So our first question gives us a graph, and it wants us to show us, or it wants to explain the amount of gas in a gas tank when a driver refills the tank on a drive across country. So as you can look at the graph, on the x-axis we have distance, and the y we have fuel. And we just put that in gallons and the distance in miles. So as the driver goes, you can see as the graph goes down right here, he is gaining miles, but his fuel is decreasing. So when he gets about to this point right here, he needs to refuel because he has run out of gas. That's why the graph goes straight up in a vertical line, because he's not going anywhere, but he is gaining fuel. And as soon as he finishes refueling, he's on his way again. So then we see the decrease line in our graph, which shows that he is once again traveling, and our fuel is decreasing and our distance is increasing. Okay, our next graph is the height of an elevator stopping at each floor on the way up. And because we don't know how long he stopped, or the elevator stopped on each floor, we just kind of guess at that. So our x-axis is the height to the next floor, and the y-axis is time the elevator has stopped. So the elevator goes up, and when it stops, the line just is a horizontal line on the graph, because it's not moving anywhere, but the time is still going because the time doesn't stop. And then he moves up again. So the elevator goes up, our height goes up. When he reaches the next floor, he stops, and we can see that on the graph because once again, it goes horizontal. Okay, and our next graph is the height of a bouncing ball dropped from a table. So if we drop a ball from a table, the first drop is going to be the highest because it's got the most potential energy as soon as it drops. Now each drop after that's going to be shorter, and the drop won't be as far. So when the first drop, the ball's going to go up highest and it's going to go the longest. And each drop after that, it just decreases in height and speed, but also the time. So we can see here the time increases as the height decreases. And our last graph, it is to show the length of a shadow of a flagpole while the day progresses. So we have a sunny day, and we start out and our length of the shadow is short. But as the day goes on, it gets longer and longer. About noon, when the sun's directly over, it's going to be our shortest, and then when the day goes longer, the shadow will get longer again. As we see on our graph here, the length of the shadow increases as the day goes on until we hit about the noon mark, and it will be the shortest, and then it increases again. All right, number 2, the function machine. So we are given that x equals 0, 1, 2, and 3. And every function machine has a rule. Our function machine rule is multiply by 3 and add 8. So our input is going to be 0, 1, 2, and 3. So when we multiply 0 by 3, we get 0 plus 8 is 8. And 1 times 3 is 3 plus 8 will give us 11. 2 times 3 is 6 plus 8 is 14. And 3 times 3 gives us 9, plus 8 is 17. And the numbers that we get after we put our input into the function machine is our output. And here we can see another way of saying it is g of f of x. And we just substitute the numbers in, and it will get the output. And there's our graph. So when g of f of x equals f of x plus 8, that's what gives us our final answer, our final output. All right, on to number 3. Explain the slopes of the line segments determined by the given pairs of points. Tell whether the segment is vertical, is horizontal, slopes upward to the right, or slopes downward to the left. Okay, so our first one here, we see we have a line, and it looks as though it slopes downwards and to the right. Our first point is 3, 1 and 5, 1. So we just make a table with our points that were given, and we're going to find the slope. So to find the slope, we're going to use our slope formula. And remember, the y-axis is the rise, and the x-axis is the run. Slope equals rise over run. And our formula is going to be m equals y2 minus y1 divided by x2 minus x1. So m will equal 5 minus 1 over 5 minus 3. Our final step is to divide 4 divided by 2, which gives us 2. So we know our slope will be 2. Okay, and the same with this one. We have 2 new points. It is 5, 8 and 5, negative 8. Now we can see by this graph that our line is straight up and down. So what does that mean? Whenever we put our points into the formula, we're going to get a negative 8 minus 8 divided by 5 minus 5. When we have two negative numbers, we're going to add, and you keep the sign, so it's going to be a negative 16 over 0. Now, if you have this and you get any number divided by 0, it's going to be undefined, which means we do not have a slope, because we cannot have a slope of 0, because that means we have no slope. So if we get anything over 0 or 0, our slope will be undefined. Okay, and our next one is negative 1, negative 4, and negative 4, 13, negative 13. And there's our table where to put our x and y at. Whenever we put our points into our formula, we're going to end up with a negative 9 divided by negative 3. And remember your rules for dividing negative numbers. When they're both negative, you're going to get a positive answer. And our slope for this line is a positive 3. Okay, so number 4, we're going to show the similarities and differences between the functions. Okay, so we have x, and we have negative 2, negative 1, 0, 1, and 2 for x. And whenever we substitute these numbers in for x, we have 3 different functions here. We're going to get different answers. And based on that is where our line's going to lie on the graph. So when we put negative 2 in for x squared, any number times itself is going to be a positive. You'll never have a negative number when you square it. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And then we know that that's where that line is going to lie based on the points that we get from doing our different functions. And as you can see, our lines are pretty much the same. The only difference is where they lie on the graph. All right, so now number 5, we're going to explain the equation of the line through the given point that is perpendicular to the given line. So what we are given is y equals negative 3/4 x plus 5, and our point is 6, negative 1. So we're going to use the point slope formula to find out that our slope is 3/4. And remember that whenever you do the slope, you're going to take the reciprocal, and that's going to be the perpendicular slope. So the negative 9 here after that is going to be our y-intercept. So when we want to check our work, we're going to substitute our x value, which is 6, into the equation, and we get a negative 1. And we know that that checks out because negative 1 is our y value. And our next one, we have 2y plus 9x minus 5 equals 0 with a point at 0, 3. And again, whenever we put this into, well, we have to simplify it first to get y by itself. When we get y by itself, we get 9 over 2x plus 5 over 2. Our perpendicular slope is 2 divided by 9 because we're going to take the reciprocal of 9 over 2. And again, if we want to check our work, we're going to substitute our 0 in for the x value. We're going to end up with 3, and we know that's correct because 3 is our y value. And we're going to go to number 6 now, and it's the equation of a line that is tangent to the circle of the radius 9 at 0, negative 9, and whose center is at the origin. So at first we need to remember that an origin is always going to be at the center, and we know the radius is 9, and one point is at 0, negative 9. So based on that, we can use what we know and substitute it into the tangent line equation. And whenever we do, we're going to get y minus a negative 9 equals 0 minus 0. Multiply that by x minus 0 divided by 0 minus a negative 9. And y is going to equal negative 9. So we know that that is where one of the tangent lines will be. It's at 0, negative 9. And remember, a tangent line is a line that touches the outer area of the circle only once. So it's not going to go through the middle of the circle or any other point through the circle. It's only going to stay on the outside of the circle. And we can see our other point. It should say 0, positive 9, not 9, 0. But 9, 0 is a point. It would be our right point because we go out 9 or up 9, right here. 9, 0 is a point. Another one is negative 9, 0. And then we have 0, 9 and then 0, negative 9. All right, and thank you for watching, and I hope that you guys have learned something today. And if you have any questions, just let me know.